Hello there, this is Miss Doolittle again with another video for you on quotient of powers property. Okay, so a quotient of course refers to division. So now we're going to be talking about dividing these things. So let's go ahead and get started. All right, now the general rule is when you are dividing powers, if the bases are the same, this part should sound familiar. If the bases are the same, this time we are going to subtract the exponents. So when we are dividing powers where the bases are the same, we are going to subtract the exponents. So let me show you where this comes from. Okay, a to the fifth power. At this point, you guys should be pretty familiar with the idea that this is 5 a's being multiplied together. And on the bottom, I have 2 a's that are being multiplied together, right? Well, when you take a divided by a, anything divided by itself is 1, right? So these guys simplify themselves out of there, okay? Same as the next set. So I can say this a and this a simplify out of that fraction. So what am I left with? I'm left with an a being multiplied together 3 times, which is a to the third power, okay? Again, just like in one of the earlier videos where I mentioned you can do this same type of problem, expanding these things out over and over and over and over again. And what you're going to find out is when I have the same base, that's supposed to be a 2, by the way, not a 3, sorry. What that means is I can take that same base and just subtract those exponents. A to the 5 minus 2 power is the same as a to the third power, okay? So, and of course, doing it this way, you're going to get to the point where you don't even have to write out this middle step. You would just be able to say a to the fifth divided by a squared is a to the third. And that's a whole bunch more efficient than writing out all of this stuff over here, okay? So that's why we have these rules intact so that we can make our lives a little bit more efficient. Okay, next problem. The reason I wanted to do a problem like this is because I wanted to point out, whoops, I didn't change this one. Sorry about that. We don't need to do that again. But I wanted to point out that when you just have a plain old number divided by another number, we're just going to divide those like we always have, right? So 21 divided by 7 is 3, and that 3 is going to live up in the numerator, okay? All right, now we have m to the 8th divided by m to the 3rd. That is going to be m to the 8 minus 3, which is going to equal 3m to the 5th power. And I don't even need that fraction bar in there, okay? All right, so sorry, I forgot to change this when I was making the PowerPoint. Let's go ahead and make another one really quickly. Let's say we're going to do 3x to the third y divided by 5y squared. Let's mix things up a little bit here, okay? So this is a little bit different. Now, can I take 3 divided by 5? Is that going to give me something reasonable and easy to express? Not really. Okay, those two aren't divisible. So we're going to leave the 3 in the numerator and we're going to leave the 5 in the denominator because remember, we're looking at just keeping things as simple and as clean as we can possibly make them. So if we go dividing that, if you actually were to punch in 3 divided by 5 in your calculator, you're going to get a decimal value. We don't want to start mixing up decimals inside of fractions. That is certainly not keeping things looking as simple as we can. Okay, so we're just going to leave it with the 3 and the 5. Now, the x to the third power, I don't have another base of x anywhere in this problem. So that x to the third power is just going to remain an x to the third power still in the numerator. All right, now, here's the thing. Here's the reason I wanted to do a problem like this with you. This, remember, is a y to the first power. That is actually a phantom 1 in the exponent. So don't forget that. That 1 is there and it's important. Now, the place where you have the greater number of y's, if you will, is in the denominator. Okay, so that's kind of where we're going to anchor this problem. So this thing is good. The y is going to remain in the denominator. I've got an exponent of 2, but I'm going to have to subtract the exponent of 1. Okay, so the actual variable is going to remain on the level of the fraction where it has the greatest presence, if that makes sense. Okay, so where its exponent is the greatest. All right, and y squared is where I have the greatest presence, or the greatest exponent. So that's where I'm going to do the subtraction, is down in the denominator. So the 3x to the third stays the same. And then I have my 5, and y to the 2 minus 1 is just y to the first power, which of course phantom 1, and typically we would not write that 1 in the exponent position. All right? Okay, let's do a few problems together. Just like in the earlier videos, if you guys would like to pause the video here and try to work that out, feel free, and we'll check when you get back. Okay, here we go. So we have, remember, phantom 1's all over the place, right? This is where phantom 1 actually really starts to come in handy, that idea of it. Every time that circle pops up, it means my mark is going to go away. So sorry about that. That's supposed to be a multiplication sign, not a negative sign. Okay, so this is 1 times r squared. Down on the bottom, I have 2r to the third power, okay? I'm going to leave my 1 on top. I'm going to leave my 2 on bottom, and there's a reason for that. Okay, so bear with me here. Where is the largest presence or the greatest exponent of my variable r? It is in the denominator, so that's where we're going to stay. We're going to keep that r to the third, but now we have to do a minus 2 because we're taking away those 2 that were in the top. Right? This would have been an r times r, just 2 of them. And in the bottom is r times r times r, 3 of them. So from the bottom, we are taking away 2 of them. And you remember, take away is subtraction. That's how we talked about that back in elementary school. Okay, so that's the reason I left my 1 up top, and that we want to talk about that, because there's nothing else there. And sometimes people will make the mistake of saying, well, there's nothing there, and because they're telling themselves the word nothing, they think it's a 0. Well, it's not a 0, because 1 is always hanging around. Phantom 1 is always there, okay? Then on the bottom we have 2r to the first power, okay? Phantom 1 there as an exponent, but you don't have to leave that. You actually typically would not leave that phantom 1 there. You would, I'm going to get rid of that so you can see what this should look like. Whoa! We need to leave the r though. There we go. All right, the 1 up top, of course, has to stay there as a placeholder. It is no longer gets to be a phantom 1. It cannot disappear since it's the only thing there. It has to show up. Okay, go ahead and pause and work out number 22. Okay, here we go. So remember, this is a phantom 1, x to the negative first power. Now this one's a little different. We got a negative up here. Okay, so I want you to watch how this works out. Just like in the last problem, I'm going to leave my 1 up top. I'm going to leave my 4 down bottom. I can't really divide those and make them any simpler, so I'm just going to leave them as they are. Now, the greatest presence, if you will, of my x variable, in other words, my largest exponent, it's down in the bottom. So I'm going to base everything from that level. So x to the 4th. Now remember, we subtract the other exponent, but that other exponent is a negative 1, so I have to subtract a negative 1, okay? So this becomes 1, that's all I have up top, so remember, it can't be a phantom anymore, it has to stay there and make itself visible. I still have my 4 in the denominator, x is my variable, 4 minus negative 1, pardon me, that means take away the negative, right? So this becomes 4 plus 1, which is 5. okay, to the 4 plus 1 power, which is 4x to the 5th. Now, I also want to talk to you, I want to just bring this idea back to you that remember what we talked about in one of the earlier videos, is that the negative in the exponent means to take the base with its exponent and move it down to the other level. So if I were to take this x to the first power and move it down here, then instead of just having these 4 x's, now they're going to be joined by this x, which actually would give me x to the 5th power. Okay? So all of that stuff that you learned before is holding true in this case. Okay, you guys go ahead and try number 23, and we'll check when you get back. All right, here we go. As I stated in the earlier example, when you have numbers that can be divided, go ahead and simplify those. So 3 divided by 3 is just 1, right? Is 1. So what I'm going to do is leave a phantom 1 in both the top and the bottom. Now, we have a greater number of n's in the top, so we're going to base this whole thing from the top. That's n to the 4th power, but then I have 3 of them that I need to take away. So take away 3. Okay, what does that leave me with in the numerator or in the denominator? It leaves me with no variables left, right? But I do still have my phantom 1. Okay, so n to the 4 minus 3 is just n to the 1st power, which remember we don't have to show that exponent up there. And then that would normally be, technically it is divided by 1, but it's a phantom 1, and when phantom 1 is in the denominator, it does not need to show up as a placeholder. We're used to looking at things that way, okay? All right. Number 24, if you guys want to give that a shot, we'll check when you get back. Okay, here we go. Remember, this is a phantom 1, right? So m to the 4th divided by m to the 4th. What am I going to do with that? Well, we already know from way back when that anything divided by itself is just 1, right? Or even if we follow the rule that we've talked about here, this is going to turn into m to the 4 minus 4. Well, 4 minus 4 is 0, and anything ever to the 0 power is 1. So what that means is that our variable is going away. So all we're going to be left with are the numbers. Phantom 1 now has to show up. It doesn't get to disappear anymore, and we still have the 2 in the denominator. But our variables have actually simplified out of this problem. Okay? All right. I've got another one because these tend to get a little fuzzy for people. Okay, so if you still have a little bit of time you can put in, we're going to try and get these done. So go ahead and pause the video, try to work out number 25, and then push play so we can check your answer. Okay, so here we go. Remember, we're going to leave the 3 where it's at. I really don't have anything to divide it with. There is a phantom 1 on bottom, not that that's going to do much for us, but now we have got an m to the negative 4th power in the top and an m to the 3rd in the bottom. So the m to the 3rd is like the greatest presence, if you will, of that variable. So we're going to leave the m to the 3rd in the bottom. We're going to have to subtract off the negative 4. Okay? So this is going to be a 3 in the top. Remember, phantom 1, I've got something else in the denominator, so phantom 1 doesn't have to show up, and we can, or doesn't have to show itself. My m, its exponent becomes 3 minus negative 4. Well, that's the same thing as 3 plus 4, which is 7. So this is 3 over m to the 7th power. The other way, remember, you can think about this is that m to the negative 4. The negative means the m to the 4. All 4 of these m's are going to go live in the other level. So now I have 7 m's living downstairs. So either way you think of it, you get the same thing. Okay, go ahead and work number 26. We'll check when you get back. Okay, here we go. So we're going to leave our numbers where they are right now because they don't divide nicely. So we're just going to leave them there. We're not going to make decimals or anything crazy like that. Okay. Now I've got an x to the 4th up top, but I have to take away the 2 at the bottom. okay? Now in this one, the y's are a little bit weird, but I want you to remember that we're looking for the greatest value of the exponent. The greatest value of the exponent is wherever that's located. That's where we're going to leave our variable. Well, -3 is actually greater than -4 if you think about that on a number line. Like here's 0, right? -1, -2, -3, -4. So the numbers further to the right are your larger values. So we're going to say this is y to the -3, but then we have to take away -4. Okay, and with my z's, obviously the z's are going to stay down at the bottom as well because 4 is clearly bigger than -3. So this becomes 4 minus -3. All right, so now we get to simplify this. So 2 with the variable of x, but then 4 minus 2 is 2 over 3 y to the -3 minus -4. That is -3 plus 4, which is just going to be a y to the first power, but we don't have to show that exponent of 1. And then we have a z to the 4 minus -3. Minus -3, of course, is a plus 3, so 4 plus 3 is 7. So there you go. That big old mess up there cleans up to be 2x squared over 3y times z to the 7th power. Take just a minute and work out number 27. We'll check when you get back. Okay, so in this one, my 4's are going to divide away. It is going to leave me with a phantom 1 on top and a phantom 1 on bottom. All right, I've got an x to the 0 power. Well, remember, anything ever to the 0 power is just a 1. So when you simplify that out and you write it just as a 1, 4 times 1, of course, is 4. So here we're playing phantom 1 again. This thing doesn't even need to show up, right? So the only x I have now is in the denominator, so it's just going to stay there as an x to the first power. My y to the -2 power, remember the negative means take the base and the exponent and move it to the other level. So I now have a y squared living in the bottom or the denominator of my fraction, and z to the third is just going to remain z to the third power, okay? So this is just z to the third over xy squared. All right, take just a minute, work out number 28. We'll check when you get back. Okay, so in this problem, again, just like up above in number 26, we have a 2 and a 3. Those do not divide nicely, so we're just going to leave those numbers exactly where they are. We'll not disturb them. H to the third power, this is the only h variable that I have, so it is going to remain where it's at. Then I have a j to the first power and a j to the -3 power. Well, of course, the first power has a bigger presence or a greater value, I can say, in the denominator. So we're going to leave it in the denominator. So this becomes 1 minus, we have to take away the -3 from the top. So minus -3. And with my k's, I have a greater presence, if you will, or a greater exponent value of 4 up here. So we're going to leave it exactly where it's at. But I do have to take away that k to the first in the bottom. Okay, so this is going to be a 2. H to the third, k to the 4 minus 1 is k to the third over 3j, and 1 minus -3 is the same as 1 plus 3, which is 4. Okay, so 2h cubed, k cubed over 3j to the 4th power. So there you go. That is how you work quotients of powers. This one was the longest one yet. I am so sorry. If you guys have any questions, please feel free to reach out and let me know. Bye-bye.